Hi, scientists. We are going to be looking at our next aspect in our Earth in Science concepts, and that's with the sunrise and the sunset. A great image here that they took in a cornfield in Minnesota. What I think is great about it is when you have that flat plain, you can see that horizon and just how that sun is changing in our sky. So a neat picture, and think of Minnesota being where compared to Indiana. They are north of us and northwest, well, more like just straight up, yeah, little west, but more north, definitely. So sunrise and sunset. So we are going to read and answer some questions along the way. Let's see how you do. The sun has come up in this picture. It's sunrise. What direction are you looking? What do you think? The sun always rises in the east. If you are in Portland, Maine, the sun rises in the east. If you are in Portland, Oregon, the sun rises in the east. If you are in Raleigh, North Carolina, the sun rises in the east. If you are in Brownsville, Texas, or Broken Bow, Oklahoma, the sun, yep, you guessed it, still rises in the east. Wherever you are on Earth, the sun is going to rise in the east. And that has to do with the way Earth is rotating. In which direction does the Earth rotate? Do you remember? Yeah, it's not clockwise, but counterclockwise. And because of that, everyone from the east is going to see that sunrise. So no matter the different locations, there's Minnesota right here. So yeah, definitely more northwest from us. So no matter if you're on the east coast, if you're on the west coast, if you're north, if you're south, you're going to see that sun rise in the east. It always does. And looking at this picture, the sun is just about to go down. It's sunset. What direction are you looking now? So think about our work with shadows. What direction would that be? Yep, it's the west. The sun always sets in the west. So again, if you're in Portland, Maine, the sun sets in the west. If you're in Portland, Oregon, the sun sets in the west. If you're in Raleigh, North Carolina, the sun sets in the west. If you're in Brownsville, Texas, or Broken Bow, Oklahoma, the sun sets in the west. We get it, right? Whenever you are on Earth, the sun is going to set in the west, again, because of that rotation of Earth. Every day, the sun rises in the east and sets in the west. To get from east to west, the sun appears to slowly travel across the sky. The early morning, when the sun first comes up, it is touching the horizon in the east. So just like in that cornfield. And then at noon, the sun is at its highest position in the sky. And then at sunset, the sun is touching the horizon in the west. So how does the sun change in our sky? It goes from east to west, yes, but it is low to the highest point and then low again. Okay? Looking at some shadows here. There's one thing you can depend on for sure. The sun will come up tomorrow morning. You can be sure it will come up in the east. When the sun is in the sky, you can feel its warmth, especially if it's not cloudy. At the end of the day, it will set in the west. You can count on it. And in fact, how long, how many days, or how many hours does it take for a day? 24. Yep. As long as day goes along, it looks as though the sun travels across the sky from east to west. During the morning, it rises higher and higher in the sky. At noon, it is at its highest position in the sky. From noon to sunset, the sun continues to travel west, and it gets lower and lower in the sky. At sunset, the sun disappears below the horizon in the west. Another day has passed, and tomorrow will be the same. So when make sure we understand a day is 24 hours, but daylight is just that sunrise to sunset. So you can see He is not opaque, so he's creating a shadow. And as the day goes on, his shadow would change. But of course, if he moves, the shadow will change. So we can't really tell unless we know what time of day it is and what direction they're pointing. We can't tell if the sun, it direction it's in. Um, we would need more information from that. So we do know it's on the opposite side of them, right? And we know it is going to east to west. We know it's on the upside of him and it's going east to west, but it's harder to tell if it's for sure what time of day. This looks to be more like it's around noon, just looking at the size of his shadow as well. So something to think about if you're looking at time of day, look at the way it's pointing and the size of it. So let's talk about Earth's rotation, which is making all of this happen, right? The sun looks as though it's moving across the sky, but it really doesn't. You know that, right? It is Earth that is moving. Here's how it works. Earth is spinning like a top. So, like one of those toy tops that you can spin. It takes 1 day or 24 hours for Earth to rotate once. Because Earth is rotating half of the time we are on the sunny side of Earth. We call the sunny side day. The other half of the time we're on the dark side of Earth. So that's why it's 50%, right? 50% of Earth is in light and the other one's in dark. So we call this dark side night. Imagine it's just before sunrise. And a lot of times, right now, when we're getting on the bus, that sun is still rising. You can't see the sun because you are still on the dark side. So when we see all those pretty colors, like we were seeing just in the opposite, the sunrise and even in the sunset, we're getting all those different colors in our sky. And that's because we're not quite all the way there yet. So we might not see the sun, but we can just see the brink of it. So you can't see it because you are still on the dark side of the Earth. But in 5 minutes, Earth will rotate just enough for you to see the sun come over the horizon. That moment is sunrise. Earth turns towards the east, the direction of the orange arrow. That means the first sunlight of the day will be in the east. And of course, Earth keeps turning. You keep moving with it. In 4 or 5 hours, you have turned so far that the sun is high over your head. In 5 hours after that, the sun is low and in the western sky. So if we're here, there's the Great Lakes, we would be morning, right? And then we're getting to noon because the sun would be right over our heads. And that way, then it starts moving more west and we would see the sunset to the west. So when in this is because Earth is moving in an eastward direction. It looks as though the sun is moving across the sky in the westward direction. Finally, it is sunset. The sun slips below the horizon in the west. It is dark again. And something to think about is, as far as our nation goes, some of the prettiest sunrises are when you're on the East Coast because if you're facing off the water, so it's like the sun is rising right above the water. And then if you're on the West Coast, it's a really pretty sunset. Not that they're not pretty anywhere, but just right off that water. And a lot of us travel to Florida, especially spring break coming up. So think about where you are in that foot of Florida there, in which direction you are facing. So even if you are on the Gulf side, so on this side of Florida in the Gulf of New Mexico or Gulf of Mexico, then you were kind of seeing that sunset over that water more so than seeing it over land still. So you kind of in Florida you get both really pretty sunsets and sunrises depending on which side you are. So a couple other things to think about is how our axis is. The X shows where your position just before sunrise. So see how it's right here just before sunrise, and it's spinning right counterclockwise, And then the X shows the position just after sunrise. So now we're in the sun. We have that sunlight. And then around noon. So see how the sun is not directly over us, because then that wouldn't be the axis, right? So our axis is tilt to that many degrees. And remember, the Earth is perfect, not, well, I can't say perfectly, but that equator is the closest line always to the sun. So we're in the northern hemisphere. That's why it doesn't look like it's the sun's right over us. A little bit more about shadows. A shadow is the dark area behind an opaque object. It is created when an object blocks sunlight. A steel pole, like flagpole, casts a shadow. The direction of the pole's shadow changes as the sun's position changes. At noon, the sun is highest in the sky. Noon is also when the flagpole's shadow is the shortest. So remember, there's two ways that our shadow changes. What are those? It's the direction and it's the size. So it changes in those two ways. We can watch the noon shadow to see how the sun's position changes from season to season even. So not just in the course of the day. The length of that shadow changes a little bit every day. Why does the length of the shadow change? It changes because the position of the sun at noon changes a little bit every day. So if we see this tree throughout the day, and if the sun's rising in the morning, that must be east, because we can see the opposite direction of your shadow. And then it's noon, so it's directly overhead. And then it is the smallest it is, because look, you can see the trunk there. And then at noon, you can't, it's right up to it. And then this is like if you were on the equator, it would be like the perfect over your feet or over the tree shadow. It wouldn't be off to the side as much. And it is here because we're in a different hemisphere. We're not right on the equator. So this is more towards late afternoon, going back over here to the west. So if you look at this diagram of showing the sun's portion, so that's the shadow, you can see it's up at the east, right? And so the shadow was here. The shadow is its longest when it comes up, and when it goes down, it's the shortest at noon. But also the sun's relationship is it's lower in the sky and then gets higher in our sky visually at noon, and then goes back down in our sky. Remember, the sun's not actually going down, right? So we'll move on next time to, well, actually we have one more page. My bad. So now moving on to not just one day, but those actually throughout the year. So in our hemisphere, when we are seeing a summer path, the sun has more of an arc. So our sun is getting higher in our sky, and then look what happens to our shadow at noon. It's smaller, right? So it is still when the sun comes up, it's still going to be longer, but not as long as it is in winter, because the sun has that lower arc, and it has to do with our axis tilt and our revolving around the sun. So let's read a little bit about that. The pattern of change is predictable. In North America, so that northern hemisphere, the position of the noon sun gets higher in the sky from December 21st to June 21st. On June 21st, the sun is the highest in the sky. Guys, this is why they call that the first day of summer. It's because it's the highest it's going to be. And so it initiates that. And that's also the day when the flagpole is the shadow at noon is going to be the shortest of the year. The position of the noon sun gets lower in the sky each day between June 21st and December 21st. So if you were to shadow track this every single day from June to December, it would get smaller and smaller and smaller and smaller. Until June, and then vice versa if you were tracking that way. So depending if you were going forward or backwards from one of those dates. The sun's position in the sky changes in two ways, like we just talked about. Every day the sun rises in the east, appears to travel across the sky, and sets in the west. The other way the sun's position changes is in its path, daily path. In summer, the sun's path is high in the sky. In winter, the sun's path is lower in the sky. So those two different types of changes is the movement, right, and the size of the shadow then too. So the sun has a relationship with that. Now we are officially done reading, and next time we look, we'll be looking at different things in our night sky.